In this episode, we are focusing on a part of data governance that becomes incredibly important the moment anyone asks a hard question about an artificial intelligence (AI) system, where the data came from, how it moved, what happened to it along the way, and whether the organization can prove that story with confidence. For brand new learners, data lineage and provenance can sound like technical record-keeping terms that belong in the background, but they are much more than that. They are the evidence trail that supports trust, accountability, reproducibility, compliance, and risk response when a team needs to explain how a system was built or why it behaved the way it did. If an organization cannot defend its data story under scrutiny, then it becomes difficult to defend the model, the testing, the deployment decision, or the claims being made about quality and control. That is why lineage and provenance are not paperwork for after the fact. They are part of building a system that can be understood, challenged, and governed responsibly from the beginning. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful place to start is by separating the two ideas clearly. Data provenance is about origin. It asks where a piece of data came from, who created or supplied it, under what conditions it was collected, what rights or restrictions attached to it, and why the organization believes it is appropriate to use. Data lineage is about movement and transformation over time. It asks how that data traveled from source to storage, through cleaning and labeling, into training or evaluation sets, through later revisions, and into any downstream products, decisions, or records. The two ideas support one another. Provenance without lineage tells you where something began, but not how it changed, while lineage without provenance can show movement without proving that the starting point was lawful, reliable, or fit for purpose. Good governance needs both. An organization has to be able to say not only this data came from here, but also this is what we did to it, this is which version we used, this is who approved it, and this is why that path made sense at the time. One reason this matters so much is that AI systems often create confidence faster than evidence. A model may perform well enough in testing to convince leaders that the project is ready, and users may quickly begin relying on the outputs because the system feels helpful and efficient. But the real pressure usually arrives later, when someone asks why certain outcomes occurred, whether the data reflected the intended use case, whether sensitive material entered the pipeline, whether a vendor source was trustworthy, or whether later changes altered the system in ways that were never reviewed properly. At that point, loose memory and vague assurance are not enough. The organization needs a defendable record. Strong lineage and provenance make it possible to reconstruct what happened without depending on guesswork or the memories of a few individuals who may no longer even be on the project. That is why mature teams treat the data story as a controlled asset. They understand that when the data story is weak, every other governance claim built on top of it also becomes weaker. The first practical question in provenance is always source. The team should be able to explain where the data originated, how it was obtained, and why that source was considered acceptable for the intended use. A source may be an internal business system, a licensed external provider, a public repository, human-created annotations, customer interactions, academic material, or a combination of several of these. Each source brings different questions. Internal data may still carry confidentiality limits, quality problems, or original purpose constraints. Vendor data may arrive with polished packaging while hiding uncertainty about collection conditions or rights. Publicly accessible material may still involve legal, ethical, or operational limits on reuse. Strong provenance does not stop at naming a source category. It captures enough detail that the organization can later show what specific source was used, what terms or approvals applied, what assumptions were made about reliability, and what concerns were known before the data entered model development. That level of clarity is what makes provenance useful under scrutiny rather than merely decorative in a project file. Source alone, however, is only the first layer. Provenance also requires context about how the data was created or collected, because that context shapes what the data really means. A historical case file might look like objective information until someone notices it was created in a rushed process, under uneven standards, or for a purpose very different from model training. A set of human labels may look authoritative until the team learns that annotators received inconsistent instructions or lacked the expertise needed for difficult cases. A data feed from another system may appear complete until it becomes clear that missing values were routine and that certain groups were underrepresented from the beginning. Provenance should therefore include the conditions of creation, not just the name of the source. Who created this record? Under what rules or incentives? For what original purpose? With what limitations, omissions, or expected variations? These questions help an organization avoid one of the most common failures in AI governance, which is treating all data as if it were neutral raw material rather than evidence shaped by real human processes and real constraints. Lineage becomes more visible once the data enters the organization's own environment. From that point forward, a defensible record should show how the data was ingested, where it was stored, what pre-processing occurred, how it was cleaned, how fields were transformed, whether any data was excluded, whether labels were revised, and what logic governed those decisions. Many project failures occur in this middle space because teams know where the data started and know where it ended up, but they cannot clearly explain the steps in between. A column may have been removed because it looked noisy. Values may have been normalized. Records may have been merged from several sources, or examples may have been filtered out for reasons that felt obvious at the time but were never written down carefully. Later, those invisible steps become serious problems. If the team cannot describe what changed, it becomes very hard to evaluate whether the model learned from appropriate signals, whether bias was introduced or hidden during transformation, or whether different project versions are truly comparable to one another. Versioning is one of the clearest places where lineage either becomes defendable or collapses under pressure. Data rarely stays still. New records arrive, older records are corrected, labels are updated, duplicate examples are removed, and subsets are rebuilt for training, validation, and testing. Without disciplined version control, a team may know generally what data it used, but not precisely which version was active at the moment a model was trained or evaluated. That uncertainty makes serious review much harder. A result from one round of evaluation may look strong until someone realizes the test set changed quietly between runs or that feedback from live use leaked back into training before proper review. Good lineage means each meaningful version of a dataset can be identified, dated, connected to source records, and linked to the specific training or evaluation activities that relied on it. This is not a luxury for large organizations only. It is a basic condition for reproducibility, because a model result that cannot be tied to a known data version is much harder to interpret, trust, or improve. The separation of training, validation, and testing materials is also a lineage issue, not just a technical one. A team may intend to keep those stages distinct, but if the lineage record is weak, the boundaries can blur without anyone noticing. A record that began in one source may be copied, transformed, enriched, and reused in ways that make later evaluation appear stronger than it really is. A team might accidentally include very similar cases across different sets, or use corrected outputs from a pilot to retrain before those cases were properly reviewed. Without strong lineage, these problems may stay invisible because the organization lacks the trail needed to see how examples moved across stages. Under scrutiny, that becomes a major weakness. Leaders may ask whether evaluation results were trustworthy, whether the model was tested on genuinely unseen material, or whether performance claims were inflated by data leakage. A defendable lineage story helps answer those questions with precision. It shows not only that the team intended to maintain boundaries, but that it can prove where the boundaries were and how they were preserved. Lineage and provenance also matter for quality because weak data is easier to spot and correct when its history is visible. If a pattern of errors appears during testing or live operation, the organization needs to ask whether the issue began at the source, during transformation, during labeling, or when data from different environments was merged without enough caution. Without lineage, the team may guess incorrectly and fix the wrong thing. With it, the team can trace backward from a problem and see whether poor quality examples entered from one vendor, whether certain annotations were created under weak guidance, or whether a pre-processing rule removed the very context the model needed to interpret difficult cases correctly. Provenance helps explain what the data originally was, while lineage helps explain how later handling may have changed its meaning or usefulness. This is why strong governance treats lineage as a practical troubleshooting tool as much as a compliance tool. It turns quality review into an evidence-based investigation rather than a collection of hunches about where the weakness probably sits. Integrity is another reason these concepts matter. A training or evaluation dataset is not trustworthy simply because it started in a good place. The organization also has to know whether it remained intact, authorized, and protected throughout its life cycle. A weak lineage record makes it easier for accidental corruption, unauthorized edits, contamination, or deliberate tampering to slip into the pipeline without being noticed in time. An example may be mislabeled during a rushed update. A file may be overwritten. A source may be replaced with a newer extract that was never approved, or malicious content may be inserted into a data flow that lacks strong controls. When integrity is questioned, lineage becomes the path of investigation. It shows who touched the data, what changed, when it changed, and how those changes relate to model behavior. Provenance adds another layer by helping the organization show that the original material was authentic and came from a known source rather than an uncertain or manipulated one. Together, they support the claim that the data foundation was not only well chosen but well protected. These records also become essential when an organization needs to explain model behavior to internal reviewers, auditors, regulators, customers, or affected stakeholders. Many questions about a system's performance are really questions about the data. Why did the model struggle with this type of input? Why does it seem stronger in one part of the workflow than another? Why did a known edge case fail, even though overall performance looked solid? Without provenance and lineage, the answers tend to become vague. Teams say the model probably did not see enough similar examples, or that the source data may have been inconsistent, but they cannot support those statements well. A defendable record lets the organization connect output behavior to data history more carefully. It may show that certain cases were underrepresented from the beginning, that a transformation step stripped away useful context, or that a later retraining cycle pulled in examples from a new source with different characteristics. This does not guarantee perfect explanation, but it greatly improves the organization's ability to investigate and respond honestly. Third-party and inherited data introduce a special challenge because teams often trust outside sources more than they should. A vendor may promise high-quality data, strong governance, and responsible sourcing, but the organization still needs enough provenance to defend the use under its own standards and obligations. A transferred data set with glossy documentation can still leave unanswered questions about collection conditions, rights, labeling methods, representativeness, exclusions, and update history. The same problem appears with inherited internal assets. A dataset built for an older project may look convenient, yet its original approvals, source conditions, or transformation logic may no longer be easy to reconstruct. If the organization cannot defend those details, reuse becomes risky even if the file is technically available. Strong provenance and lineage practices therefore include supplier scrutiny and internal memory discipline. The team should not accept a source just because it is already in the building or because another respected party used it before. It still needs a clear, reviewable story that matches the new use case and the current governance expectations. Metadata plays a major role in making these practices workable because no organization can defend lineage and provenance through memory alone. Metadata is the supporting information that gives records their meaning and context. It may include source identifiers, collection dates, approval records, processing steps, labeling guidance, transformation logs, version numbers, access controls, quality notes, and links to the model or evaluation activities that use the data. Good metadata does not have to be elaborate for its own sake, but it does need to be structured enough that people can answer practical questions quickly. Which source did this example come from? Which pre-processing rules were applied? Which version of the data fed this training run? Which team approved the inclusion of this source? When was the label last revised? Without metadata, lineage becomes fragile and provenance becomes hard to prove. With it, the organization has a much better chance of maintaining a record that remains useful as projects grow, staff change, and scrutiny becomes more serious. Still, the goal is not to build a museum of data administration that overwhelms the people trying to govern the system. A common mistake is to generate huge amounts of tracking information without deciding what actually matters for accountability and risk management. A defendable lineage and provenance practice should focus on the questions the organization may later need to answer. It should support legal and policy review, model reproducibility, quality investigation, incident response, and change management. That means the record should be current, organized, and connected to decision points rather than buried in scattered folders and disconnected spreadsheets. Automation can help, but automation alone is not enough if nobody has defined which events deserve capture or which approvals matter to the governance story. The best systems strike a balance. They collect enough evidence to make the data history legible and reliable, but they organize that evidence so it can actually be used when time is short and stakes are high. A practical example makes the value clearer. Imagine a college uses a set of student support messages to build an AI tool that helps staff identify requests that may need urgent follow-up. Under scrutiny, the college would need to show where the messages came from, what permissions and protections applied, what period they covered, how sensitive content was handled, how labels for urgency were created, which messages were excluded, how the data was split across development stages, and what changes occurred between one version of the data and the next. If problems later emerge, perhaps the system handles certain kinds of language poorly or misses indirect expressions of distress, the college will need more than a general claim that it trained on real support messages. It will need a traceable story showing what sources were used, how those sources were transformed, and whether underrepresentation or transformation choices contributed to the weakness. That story is what allows the organization to investigate responsibly and improve without pretending the problem came from nowhere. By the end of this topic, the central lesson should be clear. Data lineage and provenance are not background technical details that matter only to engineers or auditors. They are part of the core evidence that allows an organization to defend its use of data, explain how that data changed over time, reproduce important results, investigate problems honestly, and show that the system was built on something more solid than assumption and convenience. Provenance answers where the data came from and under what conditions it became available for use. Lineage answers what happened to the data after that, which versions existed, who changed it, how it moved, and where it ended up influencing model behavior or evaluation. Together, they make the data story defensible under scrutiny. That is why mature AI governance treats them as essential. When the data story is clear, the organization is in a far stronger position to govern the system, respond to challenge, and improve with evidence instead of guesswork.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.